Greetings to Dr. Teo and Dr. Fairuz. We are from Group 8 and will be presenting our project poster. Our project is about production of acrylic acid. In this presentation, we will explain the objective, plot flow diagram, reactor design, P&ID, HAZOPs, and lastly our costing for the production plant. Without delay at any time, I, Wanama, will touch on the introduction part. Acrylic acid is produced via partial oxidation of propylene, which is exothermic reaction with acetic acid as a side products. The raw material used for the production are propylene, air, and steam. With bismuth iron molybdate as the catalyst, the production has a high conversion of 99% and yield of 90%. Next, the production of acrylic acid involves several unit operations, such as mixer, multi-tubular fixed bed reactor, flash drum, and distillation column. Lastly, the plant location is at Kerteh Terengganu, which has a direct propylene pipeline feed from Petronas. Next, I will pass to Alia to explain the objective and the block flow diagram.
Okay, so in this production plant, we are targeting to produce 5,000 tons of acrylic acid per year. And then we proceed to block flow diagram. The mixture will be initially fed by 3 different streams which consist of propylene, water and air respectively. And then the mixture will be flowed into the multi-tubular packed bed reactor at the temperature of 260 degrees Celsius and 4.2 bar to undergo oxidation of propylene to produce acrylic acid. And then the desired and undesired product will be flowed into the flash drum to eliminate the off gas, which mostly consists of byproduct and waste product. And then the outlet of liquid mixture, which consists of water, acetic acid and acrylic acid, will be flowed into the distillation column as the inlet. Since the boiling temperature of the acrylic acid is much higher than acetic acid and water, hence it will be flowed into the bottom stream as the liquid product. Next, I will pass to Shi-En to explain more about the reactor design.
Thank you, Alia. So now we are in the reactor design section, and here we use a multi-tubular fixed bed reactor, which is commonly used for a highly exothermic reaction like ours, and we decided to construct it with a stainless steel, which offers a higher resistance to corrosion. And after our calculation, we have obtained around 5,000 kg of catalyst, and reactor height and diameter of 4.25 meter and 1.28 meter respectively. Besides, we use 225 tubes with a residence time of 3 seconds and pressure drop of 0.1255 bar. And the flow in the reactor is in a turbulent flow, and the total heat transfer area required is around 120 meters squared, which is considered as sufficient for all tubes. And here shows the schematic diagram, and here is the reactor inlet and product outlet, which constructed with a stainless steel pipe, and cooling jacket works in a counter current direction, which is constructed with a carbon steel, which has a lower cost compared to stainless steel. And now I will pass to Doris for safety part.
Thank you, Shia. Here is our group P&ID drawn based on the HAZOP analysis. It is a complete representation of the process and facilities, including the illustration of the piping equipment and instrumentation. Moving on to the HAZOP study, firstly, HAZOP study helps us to ponder on the possible causes based on the deviation found. Some common causes are blockage at the pipeline, failure of valve, and no flow. Secondly is the consequences of the event, such as low conversion of product, explosion due to overheating. Next is the safeguards to prevent all the possible consequences, such as install flow indicator, temperature controller, and so forth. Lastly are some actions that must be taken by the management, such as to assign at least one operator during operation and also encourage regular checking and maintenance. That's all from me. I'll pass it to Ong Meng Han.
Hello Doris, I'm Ong Meng Han. I'll be presenting about costing. The capital cost of plant and cost of manufacturing are estimated. Bare module cost of each equipment was calculated based on Chemical Engineering Plant Cost Index and is around 5.7 million. Contingency and fee costs and auxiliary facility costs using total module cost and grassroots method are 6.7 million and 2.8 million respectively. The capital cost of plant obtained is around 9.26 million. Direct and fixed manufacturing costs as well as general expenses are included in the cost of manufacturing, and it is around 12.2 million per year. Annual profit is 3.8 million per year, and it will take around 3 years to break even and profit from the plant with 41.05% return on investment. That's the end of our presentation. Thank you.